Hi, it's the first day of February. Until now, there are over 100 million confirmed cases worldwide. With so many confirmed cases, this research aims to find out how interpretable machine learning can help us to promptly react to this pandemic. We developed a system which doctors in hospital can interact with machine learning models to find the most related features for the new virus. This is a dataset consisting of around 100 confirmed patients at the initial outbreak of the pandemic between January and March in 2020. At the initial outbreak, the hospitals in China were having a hard time taking care of patients, so we have very limited access to patients' data. Still, we find some features that can help us understand the new virus. After uploading the dataset onto the system, the server will train 4 different machine learning models to predict the severity of a confirmed patient. Let's wait for the result. In less than a minute, we have received the result. Machine learning models find several important features such as N-terminal pro-brain natriuretic peptide or NT-proBNP, C-reaction protein or CRP, and lymphocytes, and lactic dehydrogenase. These findings are consistent with a paper from Nature Machine Intelligence. They used a dedicated model to generate the decision tree to find these conclusions. Using our approach, we find even more significant features. The contribution of using our approach is that we can use general machine learning models to get the result in a minute, which saves a lot of time. Saving time is saving people in this pandemic. These are predictions using different machine learning models. There are several patients. Some are severe and some are normal. Each column are predictions by different machine learning models, some with a high accuracy, some with a high recall. While for doctors in hospital, it is more important to understand how different models make predictions, whether or not their predictions are based on reasonable medical knowledge. For example, let's take a look at the 7th patient who is severe and the model makes a correct prediction. But how? These are anonymized patient info. Doctors can make predictions based on their prior medical knowledge, and they can compare their decisions with machine learning models, as shown here. Features in green color are those support the prediction. So let's focus on features in green that explain why the model makes a prediction of severe. The gradient-boosted trees make a prediction of severe because there is an increased level of C-reaction protein or CRP, an increased level of lactic dehydrogenase or LDH, and a decreased level of lymphocyte, which is consistent with this research. An increased CRP and a decreased number of lymphocytes is more likely to lead to death. Now let's take a look at a false positive. The patient number 2 is normal, but our model makes a prediction of severe. Let's investigate why this model makes a wrong prediction. So this is the anonymized patient info. The model makes a prediction of severe because there is an increased number of N-terminal pro-brain natriuretic peptide, which is consistent with medical research from this paper. Elevated N-terminal pro-brain natriuretic peptide is associated with increased mortality in patients with COVID19. As a result, even though the model makes a wrong prediction, the prediction is based on reasonable medical knowledge. Just like how doctors make predictions, every patient is unique. There is no single criteria that suits everyone. Using our approach, doctors in hospital can understand how different machine learning models make predictions and incorporate their knowledge with model interpretation to promptly find the most important features for a new virus, which saves time and saves people. The race against COVID-19 is a race against time. and we hope our approach can help medical practitioners win the race. Thank you.